Hi kids, I hope everybody is fine. So this video is for class 9 student. We'll discuss the chapter test from L Aggarwal of Theorems on Area. We have already done the entire exercise. You can see the description box for the link. Let us start with chapter test. L Aggarwal class 9 Theorems on Area. The first sum. In the figure given ABCD is a rectangle not drawn to scale with the side AB as 4 and AD as 6. Find the area of the parallelogram DEFC and area of triangle EFG. Now look carefully. First of all, area of rectangle ABCD. ABCD. It's a rectangle, so AB is parallel to DC. No doubt in that. It is equal to length into breadth, which is 6 multiplied by 4, which is 24 centimeters square. Now look carefully. Do you see the parallelogram DEFC? The area of this parallelogram DEFC and the area of ABCD will be same, because ABCD is a rectangle, that's a parallelogram, and parallelogram within the same parallels line and having the same base. If two parallelograms have the same base and they are between the same parallel lines, then the area is same. Now look, so I can write area of parallelogram, look carefully, DEFC will be equal to area of rectangle ABCD. Why so? Same base and between same parallel lines. Look carefully. Base is same, DC, and between DC and AF, between the same parallel lines, because AB is a part of AF only, which means area of parallelogram DEFC will be 24 centimeters square. Done. Okay. Number 2. Area of triangle EFG. Now look carefully. If you have a triangle and a parallelogram with the same base and between the same parallel lines, then the area of the triangle is half the area of the parallelogram. We have done this. So we can write area of triangle EFG is half area of parallelogram DEFC. Look carefully. DEFC and EFG, they have the same base and they are between the same parallel lines. So this will be same base. Reason will be same. Same base and between same parallel lines. So this will be half into 24, that's 12 centimeters square. Done. First one, we use the theorem that two parallelograms having the same base and within the same parallel lines have the same area. And second one, we used area of a triangle is half the area of a parallelogram having the same base and between the same parallel lines. Simple. Done. Chalo. We'll look at one part B now. Look at one part B. In the figure given below, PQRS is a parallelogram, okay, formed by drawing lines parallel to the diagonals of the quadrilateral ABCD, and the diagonals are parallel to these sides of the parallelogram, which means PQ is parallel to AC also, and DB is parallel to SP as well as RQ. Okay, prove that area of parallelogram PQRS is twice the area of quadrilateral ABCD. Very easy. Just look over here. Look at this ACRS. Quadrilateral ACRS. That's a parallelogram actually, because opposite sides are parallel. And if the pair of opposite sides are parallel, it's a parallelogram. So we are talking about parallelogram ACR ACRS. Over there, area of triangle ADC is equal to half area of parallelogram ACRS. Yes or no? बिल्कुल सही है. Same base and between same parallel lines. Done. Between same parallel lines and they have the same base AC. Similarly, if you look carefully, parallelogram again, I'm talking about APQC. APQC. Over there also, area of ABC, this triangle. Area of triangle ABC is half area of parallelogram APQC. Parallelogram APQC. Yes or no? The reason is same. They have the same base AC and between the same parallel lines AC and PQ. This is 1, this is 2. Add both of them. So when you add, this becomes area of triangle ADC plus area of triangle ABC is equal to, when you add these two, half area of parallelogram ACRS plus half area of parallelogram APQC. Look carefully. Yes or no? Now, if you look carefully, area of ADC and ABC, when you add them, that becomes area of quadrilateral ABCD. And over here, half taken common. So what is left? Area of parallelogram ACRS and area of APQC. So when you add them, it becomes area of parallelogram PQRS. Look carefully. I've taken half common first. So inside bracket, it will be area of parallelogram ACRS and APQC. So when you add these two parallelogram, you get the bigger parallelogram. Done. This is what they told us to prove. Bring 2 over here. So twice of area of quadrilateral ABCD is equal to area of parallelogram PQRS. That's the proof. Done. See, the main thing was AC was parallel to PQ and SR also. So area of ADC is half area of ACRS and area of ABC is half area of APQC. Add these two. So this area plus this area gives you the area of the quadrilateral, and this area parallelogram and these two parallelogram gives you PQRS. Yes or no? Step by step. Chalo, this was easy. This was number 1, part B. Now let us look at number 2. Now look at sum number 2. In the parallelogram ABCD, P is a point on the side AB. The diagram was not there. I have drawn the diagram. And Q is a point on the side BC. Prove that area of triangle CPD is equal to area of triangle AQD and area of triangle ADQ is equal to area of triangle APD plus area of triangle CPB. Very easy. Just look over here. For the first part, if you look carefully, area of AQD, area of triangle AQD will be half of area of parallelogram ABCD, because they have the same base and they are between the same parallel lines AD and BC. Same base and between same parallel lines. Yes or no? Look at the second one now. Triangle CPD. Yeah. Area of triangle CPD area of triangle CPD will be again half of area of parallelogram ABCD. Why? The same reason. They have the same base CD and they are between the same parallel lines AB and CD. Done. Comparing 1 and 2. Suppose this is your 1 and this is your 2. So comparing these two, I can clearly say that area of triangle CPD is equal to area of triangle AQD, which was our first part. Now look at the second part. Area of triangle ADQ is equal to area of triangle APD plus CPB. Very easy. Can I write area of parallelogram ABCD is equal to area of triangle APD, this one, plus area of CBP, area of triangle CPB, plus area of triangle, this one, CDP, area of triangle CDP. Look over here. I've broken it into three parts. 1, 2, 3. Now look carefully. Area of parallelogram ABCD. Area of parallelogram ABCD. Can I write from here? 2 goes over here. Twice. Area of triangle ADQ. AQD or ADQ is the same thing. Can I write? Yes. And this is area of triangle APD plus area of triangle CPB plus, actually, instead of CDP, can I write ADQ? Yes. Area of triangle ADQ. Can I write? Yes or no? Now, twice. This comes over here. Minus. So, 2 times minus 1 time. So, 1 time remains. So, area of triangle ADQ is equal to area of triangle APD plus area of triangle CPB. This is what we were supposed to prove. Area of the parallelogram we divide into 3 parts. Okay, then area of the parallelogram ABCD will be twice of area of ADQ, same base and same parallel lines. Yes or no? And then area of CPD and ADQ is same. We have already proved. Substitute over here. Bring it on this side. 2 times and 1 time. Subtract. 1 time remains. This is equal to this plus this. Done. Now let us look at number 3. Now look at number 3. In the adjoining figure, X and Y are points on the side LN of triangle LMN. Through X, a line is drawn parallel to LM, that is XZ. Okay, meet MN at Z. Prove that area of triangle LZY, this triangle, is equal to area of quadrilateral MZYX. Very easy. Look over here. First of all, do you see triangle ZXL and ZXM? They have the same base and they are between the same parallel lines, so the areas will be equal. Area of triangle XZL is equal to area of triangle XZM, same base and between same parallel lines. Done. Same base and between the same parallel line, XZ and LM. Very easy. What I'll do, I'll add this portion on both sides. We can do in an equation same quantity on both sides. So I'll add this area of triangle XZL plus area of triangle XZY is equal to area of triangle XZM plus area of triangle XZY. I've added x, z, y on both sides. Now look carefully, these two, this portion and this portion becomes LZY. So area of triangle LZY, and then look carefully, this portion and this portion becomes a quadrilateral. Area of quad MZYX. Simple, 2 steps the sum is done. Same base between the same parallel lines. The area of these two triangles are same. Then you add this common area on both sides, will get the answer. Simple. We'll do number 4 now. Now look at number 4. Perpendiculars are drawn from a point within an equilateral triangle to the 3 sides. Prove that the sum of the 3 perpendiculars is equal to the altitude of the triangle. Look over here. First I'll draw. Suppose this is your equilateral triangle ABC. And suppose this is the altitude AM. Take any point inside the triangle P. Okay. Then drop a perpendicular on AB, drop a perpendicular on BC, and drop a perpendicular on AC. Suppose MNO. We need to prove that the sum of the 3 perpendiculars, which means PN plus PM plus PO, this is P point, okay, is equal to AM. We need to prove this, yeah. Perpendiculars are drawn from the point P, from the point within an equilateral triangle to the 3 sides. Prove that the sum of the perpendiculars is equal to the altitude of the triangle, which is AM in this case. Very easy. Look over here. I'll just join these. Okay. Now look carefully. Can I write area of triangle BPA, which is ABP, half into base into height, that is PM. This is your base, this is your height. Yes or no? Because that's perpendicular. Area of triangle PBC, say half into base, which is BC, and height, which is PN. Area of triangle APC, again half into base, which is AC, and height, which is PO. Got it? Very easy. The 3 triangles. Now add all these 3. So when you add this triangle, and this triangle, these 3 triangles, you will get the area of the triangle ABC. So when you add all these, you get area of triangle ABC. This is half taken common. This is AB into PM plus half into BC into PN plus half into AC into PO. We'll write like this only. These 3 area added gives the area of the entire triangle, and this we added. Now look carefully. Area of the triangle ABC. Forget the internal diagram. Now the internal lines. This is AM. BC is the base. So area of triangle ABC, can I write half into base into height AM? Yes. Now look over here. Half into AB. Instead of AB, I can write BC into PM plus half BC into PN plus half, instead of AC again BC, because it's an equilateral triangle. Done. Now this is half into BC into AM is equal to half BC common. So PM plus PN plus PO. Look carefully. Half BC into AM, half BC common. Half BC common. So PM plus PN plus PO. 2 BC cancels, which means AM, which was the altitude, is equal to sum of the perpendiculars from the point P. Yes or no? Very easy. Just divided the entire triangle into 3 parts from the point P, and then area is half into base into height, half into base into height, half into base into height. Add them, you will get the answer. Simple. It's an equilateral triangle. So instead of AB, I can write BC. Instead of AC, I can write BC. Done? Chalo. In this video, we'll keep it till here. In the next video, we'll solve the rest of the sum. Till then, take care and be safe. And if you like the video, do subscribe and share it with your friends.